Project 2.8, RPN Calculator. This video demonstrates and explains the functionality of the RPN Calculator. The system integrates a one-wire keypad, a 16x2 LCD, and a custom-designed PCB running on an Arduino Nano. Before diving in deeper, we must learn the difference between infix and postfix notation. Infix is the notation in standard mathematical format, where operators are written between operands, such as 6 plus 7. This form often requires parentheses to clarify operation order. Postfix places operators after operands, such as 6, 7 plus. This format eliminates the need for parentheses and allows expressions to be evaluated using a simple stacked-based algorithm. It is widely used in certain calculators and computing systems for its computational efficiency. Internally, expressions are represented using a binary expression tree structure. Each operator node connects to two child nodes representing operands or sub-expressions. Evaluation is used using post-order transversal, ensuring that all operations respect proper mathematical precedence. A key feature of this calculator is the use of its one-wire keypad. 16 distinct keys are wired through a resistor ladder to a single analog input on the Arduino Nano. Each button produces a unique voltage corresponding to a specific ADC range. Now onto some calculations demonstrating the calculator's functionality. The first is infix 9-6, in postfix 9-6-, and in keystrokes 9 enter, 6 enter minus, and the result is 3. The next is 10 divided by 6.28, which in postfix is 10, 6.28 divided. Keystrokes 1, 0, enter, 6, decimal, 2, 8, enter, divide, and the result is 1.5924. Next is 4 times 5 minus 7 plus 2, which in postfix is 4, 5, 7, 2, plus minus times, and keystrokes are 4 enter, 5 enter, 7 enter, 2 enter, plus minus times, and the result is negative 16. Next is 5 plus 7 times 6 minus 2, which in postfix is 5, 7, plus 6, 2, minus times. In keystrokes, it's 5 enter, 7 enter, plus 6 enter, 2 enter, minus times, and the result is 48. Lastly, 4 plus 2 plus 3 times 5 minus 1, which in postfix is 4, 2, plus 3, 5, 1, minus times plus. The keystrokes are 4 enter, 2 enter, plus 3 enter, 5 enter, 1 enter, minus times plus, and the result is 18. Key functional components of the code are summarized as follows. Stack.h is the custom library to manage a float-based stack used to evaluate RPN expressions. LiquidCrystal.h provides functions for managing the 16x2 LCD screen. Keys, character maps for interpreting analog keypad using values as characters, and thresholds maps analog read values to the correct character based on ADC value ranges. For the state variables, num temporarily stores the string of digits and decimal input by the user, has decimal is a flag to ensure only one decimal is entered per number, and top row holds characters shown on the top LCD row. For the keypad input handler, it continuously samples analog input from A5 until it reaches a non-zero voltage. It converts the analog values to a character using the threshold and keys arrays. The top row updater adds new input characters to top row for visual feedback. If more than 16 characters, shifts the content left by removing the oldest character. Display result on the bottom row formats the result to 4 decimal places. It right aligns the string on the bottom row LCD for clean presentation, and it updates the display accordingly. The enter key handler handles the E key, and if nothing is being typed, shows the stack's top value. If typing a number, it converts and pushes the float to a stack, then resets input flags. The operator handler attempts to pop 2 operands from the stack. It performs the math operation with a check for division by 0. It pushes the result back on the stack and updates the bottom display. In the main loop, it continuously looks for input and determines its role. In short, the calculator works with reverse postfix notation, enters numbers, press E to push them onto the stack, and apply operations. It uses an analog keypad, a custom stack library, and an LCD display to show results. It supports multi-digit numbers and decimals. And that is my demonstration and explanation of the RPN calculator. This is Project 2.8, RPN Calculator. Thank you for watching.